Bosch, and this is the CS410 project. Mine is for metrics collection for topic models using Apache Spark. I will quickly go through an overview. There is a PowerPoint document that I will only touch on, and there's a README. The repo is here. We will download that in a moment here. Before that, they'll go through a quick summary of what the purpose is. So this project provides a framework for evaluating topic models. It includes the means to collect metrics, to run some topic model algorithm, including the Spark latent directly allocation that is included in Spark, as well as an experimental version of the hierarchical directly process that was not included in Spark, but which I have done some work to make it runnable. It does have more work need to be done at the algorithmic level. But in terms of the framework here, the intention is to be able to collect log likelihood, perplexity, take a sampling of the terms within the given topics, and then be able to compare them in a manner in a straightforward manner. They are actually collected inside of a common CSV file. So this gives us a way to manage the results. To go through quickly, the primary features is we have an LDA metrics collector, which actually can store any kind of topic models, not just LDA. And so it does have some sampled data sets, including the 20 news groups, and as well as a custom generated data set that allows us to tweak the topic models in terms of the distribution of the terms. So another that is showing here a topics generator class that it uses Powerlaw Zipfian distributed set of topics or terms for in given set of topics. The way to run these are shown in the README, and we will go through that. So let's get started with actually running this. Let's go to the installation instructions. We will first go and clone the repo. So we have cloned the repo into top metrics directory. So we will. Where do we go? Installation. Okay, so let's go to the README. Looks like a where's the installation? Okay, the setup script, right? So then setup.sh. So README does mention that their prerequisites for this are to have Maven and Java installed. This is supported in, looks like that, this is an old version of the README. I need to update that. It does have, the new version does have that mention of the prerequisites of Java and Maven. And this is supported running on Mac. It should work on StarNix. It hasn't been tested on StarNix. This is building. This project is in Scala primarily. There is a Python utility for doing some data massaging for the topic models, for the 20 news groups. While that is compiling, we'll take a look at a little bit of the code that is in here. This is in the PowerPoint presentation that I'll only touch on here. It is in the docs directory of the project. there's a trait for topic generator that is that's providing generate a single doc as well as provide the probability distribution of the words within the topic. And there's an implementation of that, which is a Zipfian topic generator. It uses a Zipfian which has with a okay. It looks like the initial installation is done. So one thing to mention here is that the installation includes cloning the topic modeling project, which is a project that I have forked that was used as the original basis for the Spark LDA contribution in January for Spark 1.3.0, January 2015 for Spark 1.3.0. They had an experimental version of the hierarchical direct relay process, which does not have any launching any way to start it, and has internally some issues. I've updated it to Spark, the latest Spark. I've fixed some of the internal issues. Have provided an example program and have integrated its outputs into the metrics collector. So it has been checked out into the subdirectory, and we can go ahead and run that independently using this script run http.sh. It will go into that directory, build that project. There was an existing Maven prom.xml that's been updated for Spark 2.x, and I have pointed it to a small amount of the 20 newsgroups data here, and in order to be able to run it quickly. The logic itself inside this HTTP, it needs more work. Well, actually, it needs a lot more work. There's first of all, the algorithm itself does not seem to be improving on the likelihood in a monotonic form result. So it's just over 300 lines, the core of the algorithm, and that's something that we'll need more time to look at in the next several weeks outside of the scope of this course. Honestly, that's also what made me late for this. I just got so interested in it that I'm a few hours late on submitting this project, which I apologize for, and I'll have to follow up with. But it was integrating this HTTP that got me into that situation. I just kind of got really into it. So we do see here it's the metrics that we have the log likelihood and the log perplexity. And even after adapting 2 iterations, the same results come out. That means that internally they are not managing the results properly. And we can see there's just a lot of work that needs to be done. But there is some usable amount of code in there, so I will start with it as a starting point. Then these errors here can be ignored. They're about the Spark context not being shut down properly, which doesn't affect the output results, but it does. It just reflects that this is an immature code. However, this code, the results are being collected, and they are being used in the next results, which is in combining them in an output with the LDA output. We'll do that in a moment here. So now the next step is we're going to run the now we're going to generate the topics using a Zipfian, which we looked at. Okay, so we generated, again, I'm using a very small number of elements in terms of number of terms, the number of topics. But what we have here is use a configurable number of topics, configurable number of terms. The exponent for Zipfian is configurable, and the nice thing here is that we have clear visibility into what the terms are and which topics and how they're getting mixed. So some more details can be seen within the PowerPoint presentation on how this is generated, but the point here is this allows some very clear understanding of how the topic model is behaving, and in terms of combining this analysis with 20 newsgroups can allow you to see this end tells you sort of deterministically what does that topic model do with a very clear known distribution of terms. and then that can be seen on the 280 news groups and other open open data sets about how that works with real world data sets. So now the next step is we're going to see a little bit of that. And that's going to be, we're going to run bin run the collector. This metrics collector is going to run of both the HDP, the hierarchical Dirichlet process, super experimental pre-alpha code, as well as the production LDA code against this synthetically generated data set, as well as the 20 news, a small portion of the 20 news groups. So we're seeing this right now. It's running the HDP. It already ran the LDA. There are a total of 4 runs of the algorithm being performed. So it's this 2x2 matrix of the algorithms, LDA and HDP, versus the data sets, which are our topic generator, Zipian, and the 20 news groups. So we'll have 4 outputs total. So we're printing out some of the topic. This is for the 20 news groups against the LDA, and we can see some of the distributions of the terms. These are just the printouts, but we're going to see it a more formal structure inside of the output. So we collect the output gives us currently takes a small set of metrics that log likelihood, perplexity, the topic distributions, the top terms per topic. And we'll see that in a moment here. On the LDA side, we don't even get we only get the log perplexity and log likelihood, again, because of the limited scope of what's available in the code as it stands. So that's the second run of the HTTP. Again, the output is the error because of Spark context not being shut down properly. Okay, so now what happens is the last step in that program is it actually does calls up VI on the output. So we're having a little bit, okay, yeah. So now this brought us automatically into the generated metrics. The generated metrics, we put a CSV header that takes the maximum number of topics and any of the runs as the tail of the CSV headers. It gives us a name, but the head of them are we have the name of the test, the log likelihood, log perplexity, yeah, and then we start looking at the topic information. So we'll actually bring this up in Excel in a moment. So we have right. So we have right. So inside of the test itself, we run a few different combinations. Fake 5 is that's 5 topics, fake 10 topics, fake 20 topics, and fake meaning that's the generated data set. Then we have the online HTTP. We have 20 news. This is the 20 news group with 20 topics, 20 news group with 5 topics, 20 news group with 5 topics using the online variational Bayes. The other 2 are using the expectation maximum approach. So these are all in one spreadsheet. Let's see if we can do this. So let's bring it up in Excel. Great, it did. So you can see I just from command line I hit that and it came up in Excel, and we can see in the name of the test, log likelihood, log perplexity, and then for each of the topics, again not for the HTTP but for the LDA we have these. It gives us the first few terms of each topic and their probability. Okay, that's probably enough of your time here. I think the purpose of this was to provide a basis for being able to do careful analysis of topic models. And so this, like for example, using the HTTP is something that I would like to see if we can push ahead. Then we need to be able to show just how it compares to the LDA, but in a careful manner. against various types of data sets. And this is a tool that would be useful. Thank you.